In this question, the rule for function h is h of x equals 2x cubed plus 1. Find the rule for the inverse function h to the minus 1. So first step in finding the inverse is to swap x and y. So let y equal this function 2x cubed plus 1, and then swap x and y. So therefore you will get x equals 2y cubed plus 1, and rearrange this to make y the subject. So first step, get rid of this 1, minus 1 from both sides. X minus 1 equals 2y cubed. Divide both sides by 2 to get rid of that 2. And you have x minus 1 on 2 equals y cubed. And then last step, take the cube root of both sides, or raise both sides to the power 1/3, and 3 times 1/3 equals 1. That's the rule for when you have a power raised to a power. So 3 times 1/3, this will equal, oops, and do it to this side as well. So the 1/3, and so x minus 1 on 2 to the 1/3 is going to equal y to the 1, and so that's really just y equals all of that. So x minus 1 on 2 to the 1/3, and then the last step, this is the inverse function here, so now call that h to the minus 1 of x is equal to, and then do that again, and that's the inverse function. The domain of the original function, 2x cubed, y equals 2x cubed minus plus 1. So this is just your basic cubic graph with a point of inflection at 0, because it's just x cubed. If it was, say, x plus 1 cubed in a bracket, it would be minus 1 would be the x coordinate, and then plus 1. But because it's just x cubed, it's 0, comma 1, which is 0, 1 moved up 1, and then you've got something like that. And the domain is all R is just R, so the domain is R. It's just implied from the actual function or the graph of the function, and you can see from that that the range is also all reals. So range is also all reals. So when you swap the domain and range for the to get the domain and range of the inverse function, they are both still R. So the domain of the inverse function is also going to be R, and that is the inverse function with the domain specified, which you must do. So that's how you do this question.